All right, so this is 13 Roman to integer. So this isn't too bad. Basically, I'm going to read the problem real quick. We have Roman numerals, and we have to convert them to their numerical counterpart in pretty much base 10. So Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, and M. Here we get the values of all these Roman numeral symbols. To give you some examples, like 2 is written as II. It's just 2 1s added together. 12 is written as XII, X being 10, I being 1, and there's 2 I's, so it's 12. And they say here X plus II is 12. 27 would be 2 X's, 2 V's, and II. So that's pretty straightforward, right? The only part that's kind of confusing, right, with Roman numerals, when you have 4, you don't write I. What you write is VI. The same thing with these cases here, which they're mentioning. So I can be placed before V, which is 5, and X, which is 10, to make 4 or 9. So if you have 10 and you want to make 9, you say XI. X can be placed. Yeah. No. IX. Oops. IX. Just like you would do a IV for 4. And so you have a few more. So X can be placed before L to make 40, and X can be placed before C to make 90. C can be placed before D to make 500 to make 400, because D is 500 and C is 100. So same kind of concept here. And then M can be placed. C can also be placed before M to make 900. So M is 1,000 minus C, which is equal to 900. So we get some test cases here. IV should give you 4, IX should give you 9, and so on and so forth. So quick and easy way to do this, right? So they pretty much give us the pretty much all the information we need. So we have symbols and they map to values, and when you have symbols that map to values, the perfect data structure there is a hash map or a dictionary. So if we didn't have these cases here, what you could literally do is just iterate through the string. If you find I, look up the dictionary, I is equal to 1, and then you can just linearly summate the values of the strings. But since we have this rule here where you can place, certain characters before, what that basically means is we're going to have 2 lookup tables. And this is the most intuitive solution, I feel like. And so to save you the time of watching me type this, I'm going to paste in, first time doing this problem, by the way, I'm going to paste in a completed dictionary of these values. So we can just take a quick look at these. So symbol dict is the regular one, so it's just Roman numerals, the Roman numeral value to its numerical counterpart. And then double, which is all the possible values that you can create if you try to prepend, let's say, a smaller denomination before a larger denomination. So you get 4, 9, 40, 90, 400, 900, just like they said here. 4, 9, 40, 90, 400, 900. So once you have these, it's literally just, you're just going to iterate through the string and then add these. You're going to look it up in the table. It's either in this table or it's in this table. And so that's pretty much it. And so what we can do here, we can actually just do letter index. We're just going to start at 0 here, and we're going to iterate straight through. While letter index is less than length of S, which is the string, minus 1. And we're just doing minus 1 here. And we want to stop 1 before just because if the string, because when you have these 2, like these Roman numeral values, which are pretty much 2 Roman numeral characters representing 1 numerical value, we're gonna have to check 1 ahead of our index sometimes, and we don't want that to ever go out of bounds. And so what this is just gonna do is gonna allow us to do that without running out of bounds. But when you ever do minus 1 to start a loop, you have to have some kind of like base case even before then, because you have to consider a list of element 1. So if you think about this, if we have a list of length 1, like minus 1, and our letter index goes from the length of the string minus 1, the loop will never run. So we're just going to add that here. Before we start, I don't know why I'm in caps. If the length of the string is equal to 1, then all we literally have to do, we already have the dictionary, and we know the length of the string is 1, so it can't be in this one, right? It has to be in this one. Let me fix the spacing. We're literally just going to return symbol underscore dict sub S sub 0. Or you could actually just do S, since we know it's going to be 1. So that is going to return, the numerical value for whatever the single digit in here, and it has to be one of these. Then we can iterate through. So what we're going to do is we're going to say double Roman, right? So let's build that. Let's build that double Roman numeral value here. So we're just gonna say s sub letter index plus s sub letter index is such a long name plus 1. And so if our string is, let's just say it's I, we're just gonna say we're gonna run from 0 to 1 because we said what we said was that we're gonna run from the length of loop minus 1. And so what we're gonna do is we're gonna try and build I. Once we build I, what we're going to do is we're going to try to look it up in double dict. If it doesn't, then it means that this is just a regular, 2 single-digit numerical Roman numeral values. I guess a better example would be something like this. So if we try to build double Roman here, what we get is IV. And if we look it up in double dict, it's in there, and it's 4. So we'll build that there, and we'll say if double Roman in double dict. Now, if it is in double dict, then we just have to add it. We'll just say total, which is our value that we're going to return. I'm just going to go to the bottom and just say return total. And we're just going to do total plus equal, and we're just going to look up the value here, double dict sub double. Oops. Oh, man, I'm confused. Double Roman in, oh, no, yeah, double Roman. So we're just going to add it here. And then we're just going to increment the letter index by 2, because we know that these 2 letters can be looked up, so we don't want to check IV and then go check VI. There's no point, right? We already know that IV is one Roman numeral value, so we just want to check I here. But our loop runs -1, and we'll get to that soon. So this loop, if the number of elements is odd, then we're going to end up with 1 extra value left. And so we'll do else here. If it's not in double dict, right, then it must be in symbol dict. It is just true. And so what we can do there is just look up s sub letter index and just add that to the value. And then we're just going to increment letter index plus equal 1 here. And the final thing we have to do, and this is just because if the list is odd, we're going to have 1 extra value, just because we're going -1, so we can check 1 letter ahead. What we're going to have to do here is just go if letter index does not equal the length of s, which means we have 1 extra value left over. And what we're going to do, we're just going to add it to the total. Plus equals symbol. And we can always just assume it's going to be in symbol dict because it's going to be 1 value left. And it literally, because the way Roman numerals work, it can only be in this single dictionary here. Not equal length, and this should work. Let's give this a try. Let's give this a shot. Oh man, wait, it's unexpected. Oops, I forgot to take these out. Unexpected. Yeah, so, oh, oops. All of this has to move forward, basically. And so that works there. First time doing this problem, by the way. And so there you go, 84 milliseconds. You can't really pay attention to this here because this is definitely the fastest solution of this ever made, actually true. But this number is going to depend pretty much on how many people are running code on LeetCode right now. So it is what it is, but that is double Roman. So the time complexity here, well, sorry, the space complexity. Space complexity here is constant, right? Because what we're doing is we're just looking up values in these 2 dictionaries here, right? And if that's the case, then that means our space is going to be constant. It's not going to scale with the size of the input to the function. So we have constant space here, and we're just going to have linear time because we're linearly iterating through the string to calculate the value. So that is Roman to integer.